Hey, all, today we're going to continue talking about angle pairs and transversals. And now we're going to start talking about, though, what happens when those lines that the transversals cross are parallel to each other. So let's talk a little bit about notation. Remember that parallel lines are lines that will never intersect. And so right now I have this transversal, and it's intersecting two lines. And the way that you will be told or shown that two lines are parallel is there will be arrows on the lines. Not the ones on the end, but we'll put arrows somewhere else on the line. Something similar to this. And if two lines have the same number of arrows, sometimes it's one arrow, sometimes it's two, but if they have the same number of arrows, that's an indication that those two lines are parallel. So if we don't say the two lines are parallel, but we do show that they have the same number of arrows like this, and typically they're red, but if we don't print in color, then they'll be black. But if we do have the two arrows, the same number of arrows, that means these lines are parallel. And then another symbol that we use for parallel, if we're writing that two lines are parallel, would just be two lines next to each other like that. So some notation on how we'll express that, hey, these two lines are parallel. And so when the lines that are being intersected by a transversal are parallel, we still have all of our same angle pairs. We have alternate interior, alternate exterior, same side interior, same side exterior, and we have corresponding angles. All those things exist still. But the relationship between those angle pairs is unique now. And these only happen when we have our lines that are being intersected parallel. So what happens in this type of picture is that when we have these two lines parallel and we have a transversal, we're only ever going to get two different angle measures. You can see that some of these angles, I'll show them with this little arc and an arrow, some of these angles look the same. Those four angles should look the same. And then we have these other angles that look bigger, but they all look at the same as each other. And so at any point when we have two parallel lines intersected, or more parallel lines, we could have a third parallel line, and we'd have another group of angles that match these ones. There's only ever going to be two different angle measures. So if you know the two different angle measures, we could fill in all the angle measures in this picture. And we get these relationships, special relationships that exist between our different angle pairs. And so let's look at our alternate interior angles. We have that one and that one. We have that one and that one. It should look like the two ones that I did in orange are the same measure. That's because they are. Alternate interior angles, when I have lines that are parallel, and I should put the arrows on here. I'm just going to do these kind of arrows. When lines are parallel, the alternate interior angles are congruent. That means they're the same size. So if I know that this angle is 47 degrees, then this angle is 47 degrees. And then that would make this angle 133 and this one 133. I'm just making these numbers up kind of. So alternate interior angles are congruent when my lines are parallel. They're still in the same positions. They're on opposite sides of the transversal. They're in between the two parallel lines. We can still identify them the same way we did last time, but now we know this special thing, and it's that they're equal to each other. They're congruent. The same thing is true about alternate exterior angles. That angle there and that angle there, they are congruent. This pair of alternate exterior angles are congruent. They should look like they're the same measure, and that's because they are. There's no way for us to draw parallel lines intersected by a transversal and these angles to not be exactly the same. The last type of congruent angle pair that we have, so we have You should probably write, if you're drawing these pictures, just reinforce that these are, I'm going to shorten these. These are alternate interior. These are alternate exterior. Just reinforce the names of the angle pairs. I know I said them, but writing them down is a good idea. And then the last pair of congruent angles are corresponding. Remember, there's 4 pairs of corresponding angles. Top left, top right. Trying to color code. If color is not your thing, you can use symbols. It should look like all the angles that correspond. So the 2 orange angles look like they're the same size. The 2 green angles are the same size. The 2 blue ones are the same size. The 2 yellow ones are the same size. So if we can identify 2 angles as being one of these 3 angle pairs, we will know those 2 angles are the same size. If we can identify 2 angles are same side interior, I'm going to do SS int, or same side exterior, SS ext. If we have either one of those angle pairs, then we know they're supplementary. Reminder from the first lesson of this unit that supplementary angles add to 180 degrees. They don't always have to be right next to each other, but if they add to 180 degrees, they're supplementary. And so our same side interior angles, like those 2, will add to 180. You can see they're different. They're not the same now. They're not congruent. They're different, but they do add to 180. Same thing with these 2. And the same thing is true about our same side exterior. So one way I remember this is same side supplementary. Lots of S's. So let's put this into practice a little bit. We've already in this unit identified different angle pairs and used those angle pairs to write and solve equations. We've now added new angle pairs when we have this situation where we have a transversal. And now that we have this special relationship for those angle pairs, we can use those relationships to write and solve equations. These are all kind of the same idea, just different relationships. So you can see here I have 2 parallel lines as indicated by my red arrows. And so I need to first identify the angle pair. These are corresponding angles. If you don't pick up on why right away, please do ask for help. From a little bit earlier in this lesson, corresponding angles are those angle pairs that are congruent, which means they're equal. So I can write an equation that shows these 2 angles are equal. 36x plus 2 is equal to -1 plus 37x. And I'm going to go ahead and solve this, and then pause and solve this, and then press play. So we get x to be 3. So again, we have geometry and algebra both working together in these types of problems. The geometry is being able to identify their corresponding angles and being able to identify what that means about them, that they are congruent and they're equal. The rest is algebra. If you struggle with either of those, you need to ask for help. Please do ask for help. But right now I'm going to focus on the geometry portion. If you need some help with the algebra, we will absolutely support you in that, and you can ask us for help. Here I'm looking at these 2 angle pairs. They're both exterior angles. They're on the opposite side of the transversal, so these are alternate exterior. And so that means they are congruent to each other. They're equal. So this angle over here, x plus 25, should be equal to this angle up here, 120. And this is a bit of a quick solve. We subtract 125 on both sides and get x to be -5. It's okay that it's negative. We're not saying that the angle is -5. We're saying x is -5. And we can check our answer by plugging -5 in for x. And we can see that that simplifies to be 120, which is the same as that one, which is what we wanted it to be. do one final example. Here I have two angles. They're both inside and they're on the same side of the transversal. These are same side interior angles. Same side angles are going to be supplementary. And so that means they're going to add to 180 degrees. This angle 7x plus 12 is not going to be the same as this one that's 100. They're different. But we do know that if we put them together by adding, when you put things together, you add. I'll make a big plus to show that I'm adding that angle to this angle. When I add them together, they should be equal to 180. And so now I can do some algebra. And again, if you get stuck at some of this algebra, what I'm doing here, please do ask for help. I'm really focused on the geometry portion, but the algebra is important. We get x to be 9. And we can always, always, always check our work by plugging in our answer for x. So we could plug in 9 here and get 9 times 7 is 63, and 63 plus 17 is 80. And these two angles are not meant to be the same. They're meant to add to 180. 100 plus 80 is 180. We must have the right answer. So as always, practice is what's going to reinforce these ideas. It's going to make you more comfortable with these ideas. If you do need help, please do ask. We're glad to help you. There's two of us here. Make sure you stick around and answer the problems at the end. Take your time on those, and good luck.